Okay, hello Cloud Gurus and welcome to this section of the course. This section of the course we're going to cover off S3. We're going to learn what it is and we're going to have lots of labs and start using S3 regularly. S3 is a massive topic in both the Solutions Architect Associate and the Developer Associate exam. So you really need to have a fundamental understanding of S3 before going into the exam. And the reason for this is basically S3 has been around for a very, very long time. So it's one of the backbones of AWS. So what is S3? Well, S3 stands for Simple Storage Service, and it provides developers and IT teams with secure, durable, highly scalable object storage. Amazon S3 is easy to use with a simple web services interface to store and retrieve any amount of data from anywhere on the web. So basically, what is S3? Well, it's a place to store your files in the cloud. And actually, the founder of Dropbox used to store all his data on a USB drive. And, he'd be going into university or to college, and he just found it, troublesome. And then when Amazon released S3, what he did was he just designed a simple, web page that basically interacted with S3, which allowed him to get rid of his, USB drive and store all his data up in S3. And of course, now he is probably a billionaire, certainly a multi-millionaire. And Dropbox still leverages S3 for the storage. All the metadata themselves they do inside their own data centers, but it still leverages the backbone of S3. So what do I mean by object-based storage? Well, in storage terms, there's object-based and there's blocked-based. So an object is simply things like videos or photos or PDF documents or Word documents. They're called flat files. So that's what we mean by object-based storage. And it's fundamental to understand that S3 is not a place where you would install an operating system on or where you'd run a database from. For that, you need block-based storage. And we're going to cover that off in the EC2 section of the course. So S3 is just a place to store your files in the cloud, and the data is actually spread across multiple devices and multiple facilities. So it's designed to withstand failure. S3 is it's a fantastic service, and it's really, really cheap as well. Lots of people use S3. I actually don't even bother looking at hard disk size now when I buy laptops because I store all my files up in S3. And you can get these really cool applications like from Cloudberry Labs, which gives you your Windows Explorer style environment, but it's actually backed off into S3. So it looks like you're in a normal Windows environment, but where you're actually storing the files is in S3. So let's start with the basics of S3. So like I said, it's object-based. It allows you to store your files. It's not a place where you're going to install an operating system or run a database from. For that, you need block-based storage. Your files can be anywhere from 0 bytes all the way up to 5 terabytes in size, and there is unlimited storage. And by that, we just mean that Amazon monitor the S3 capacity around all the different regions in the world, and as and when they need more SAN arrays, they'll go in and provision them. And then files are stored in buckets, and if you're new to Amazon, it sounds a bit weird, like what the hell is a bucket? A bucket is just a folder. So think of a bucket as a folder. You put all your files in buckets, and you can have many different buckets within your S3 environment. Now, S3 is a universal namespace, and that just means that names must be unique globally. And we'll have a look at what that actually means in the lab. But if you were to create a test bucket, for example, a bucket called test bucket, you wouldn't be able to grab that bucket name because somebody else owns that bucket or owns that name. So I own A Cloud Guru, for example. You won't be able to build the A Cloud Guru bucket. And then when you create a bucket, it basically creates this DNS address. So it's always S3 hyphen and then the region. So this would be EU West 1, which is based out of Ireland, .amazonaws.com, and then / and the bucket name. And that can actually be an exam question. They might give you a whole bunch of different HTTP links, and you have to choose which one would be the correct one for a bucket. So do understand the format of bucket names. And then finally, when you upload a file to S3, you're always going to receive a HTTP 200 code if the upload was successful. And that's quite important to remember going into the exams as well. So another really important thing to understand before going into any of the exams is the actual data consistency model for S3. And if you go and read through the AWS documentation, it's always very technically accurate, but it can be really, really dry. And that's why, learning online is so much easier, in my opinion, because you can actually have people talk you through it. So the very first thing you need to understand about the data consistency model is this. It's read after write consistency for puts of new objects, and then you get eventual consistency for overwrite puts and deletes. What the hell does that actually mean? Well, it's actually really, really simple. So when you put a new object in S3, you're going to get immediate consistency. So you're going to be able to read that object straight away. So if you make a call, let's say it's a text file, and you want to read the data in there, you're going to be able to read it immediately. However, you don't get that kind of speed when you're updating or deleting an object. It can take some time to propagate. And if you think about how S3 is actually designed, it's designed across multiple devices in multiple facilities. So when you update, let's say you update a Word file, maybe you just change the date in it, and you do a read immediately to that Word file after the update. I'm talking like within a few milliseconds. You might get the new data, or you might get the old data. It takes a little bit of time to propagate so that it's completely consistent across all the facilities. And so updates to S3 are atomic. So what do we mean by atomic? Well, basically, you're either going to get the new data or you're going to get the old data. What you're not going to get is partial or corrupted data. You're going to either get the new version or the old version. So really, really important to understand those 2 points going into the exams. When you write a new object to S3, you'll be able to immediately read it. If you are updating an object or deleting an object, it can take some time for that to be consistent across inside the S3 bucket or across the different facilities. So really, really simple concept, but make sure you do know that going into your exam. So S3 is a simple key value store. And what do we mean by that? Well, basically, S3 is object-based, and objects consist of the following. So you've got your key, which is basically the name of the object. Then you've got your value, and this is simply the data, and it's made up of a sequence of bytes. Then you've got your version ID, and this is really important for versioning, and we're going to have a whole lab on versioning coming up in this section of the course. Then you have your metadata. If you're new to IT and you don't know what metadata is, it's simply data about data. So metadata might be the date that you uploaded this file, or the last time you updated it, for example. Okay, so when we put an object into S3, what is it we're actually doing? What is it we're creating? Well, basically objects consist of the following. So we have the key, and this is literally the file name of the object. So what you have to understand is S3 is designed to be lexicographical, or to sort objects in alphabetical order. And this can actually have really important design considerations, and it can certainly be a very popular scenario in many of the different exams, certainly at the professional level, but you'd also have to know this for the developer associate exam. So when, let's say you've got log data, for example, log data typically exists in a date and a time, and all the file names can look really, really similar, especially if you're writing a new file every second, for example. And then what will happen is that data will all actually be physically stored in the same sort of area in S3, and you can get performance bottlenecks. So what kind of solution should you do? Well, you can actually just add a random sort of salt at the start of the file name. So instead of it being the date, you might add a random letter or number, and then that ensures that the actual objects will be stored evenly across S3. So that is a scenario that can come up. And it's also just a really important design consideration. So if you do have file names that are very, very similar, you might want to consider just adding some randomness to the beginning of the file names. And then we have the value, and this is literally the data, and it's made up of a sequence of bytes. So the value is the data of the object that you're storing. We then have the version ID, so which version of the object is this? And we're going to have a lab on versioning coming up later on in this section of the course. And then we have metadata, and if you're new to IT, metadata sounds complicated, but metadata is literally data about data. So when was this file first created? That's metadata. And then we have sub-resources. So sub-resources basically exist underneath an object, so they don't exist on their own. And sub-resources consist of two things. They consist of access control lists, and access control lists are exactly what they sound like. So who can access this object. An access control list allows you to do fine-grained permissions. So you can do an access control list on an individual object, so on an individual file in a bucket, or you can do them at the bucket level. And we'll explore access control lists later on in this section of the course. And then you also have torrent. So S3 does support the BitTorrent protocol. So what else should you know about S3? Well, it's built for 99.99% availability, and then Amazon actually give you an SLA of 99.9% in terms of the availability SLA. And for those of you that don't know, an SLA is just a service level agreement. All infrastructure as a service providers, cloud providers always give SLAs on certain services. And then Amazon guarantees 99.9999999 durability for information on S3. And of course, you don't want to read that out every single time, so it's just called the 11 nines durability guarantee. So what do we mean by durability? Well, it just means that you won't lose a file. So it's how durable the data is. And then S3 also comes with tiered storage options. So there's different types of storage options in S3, and we'll cover that off in the next slide. We also have lifecycle management. So we have a lab on this, but basically you can say, if your data is 30 days old, then it sits in this particular storage tier. After 30 days, move it to another storage tier, and then after 90 days, archive it off into data archival. S3 also supports versioning, so you can have one object with multiple different versions, and again, we're going to have a lab on that in this section of the course. You can do encryption on S3, and there's several different ways of doing encryption, and it's really important to remember the different methodologies of encryption going into the exam, so we'll have a lab on that. And then you can secure your data in a couple of different ways. You can use access control lists and you can use bucket policies, and we're going to have a lab on the differences between those two, and it's really important to understand that going into the exam as well. So what are the different storage tiers or classes in S3? Well, currently there's just normal S3, which is called S3, and that's the one with the 99.99% availability in terms of its design and the 11 nines durability, and it's stored across multiple devices in multiple facilities, and it's designed to actually sustain the loss of 2 facilities concurrently. So it is really, really highly available. And then we have S3 infrequently accessed, and this is for data that is accessed less frequently, but still requires really rapid access when needed. So it's a lower fee than S3, but you're charged a retrieval fee. So think of an example. Maybe you've got payroll data, you've got people's wage slips all inside an S3 bucket. You don't actually need to review that until year end. But when you do need to review it, you need to be able to review it immediately. You don't want to wait for 3 or 4 hours for it to come out of some kind of data archival system. So S3 infrequently accessed would be your best, best port of call here, because basically you can store it, you can access it immediately, but it costs you a much lower fee than using S3. And then you have reduced redundancy storage, or RRS, and this is designed to provide the same availability, but the actual durability drops. So it's only 99.99%. But it is a lot cheaper than using standard S3. So what would your use case for using something like this be? Well, maybe it's data that you can generate again. So you could store all your image files in one bucket, but then the thumbnails in another bucket. And with the thumbnails, you could use RRS, so that if a file goes missing, you can just regenerate the thumbnail and it will save you some money on storage. And then finally, we have Glacier. So Glacier is very, very cheap, but it's used for data archival only, and it takes 3 to 5 hours to restore from Glacier. And that is something that's going to come up constantly in your exam. So you might have all these different storage options, and you want to save the most money, and it will come down to retrieval time. Do you need to be able to retrieve an object within a few milliseconds, or do you need to be able to retrieve an object within a few hours or even days? And then also you have to take in the cost considerations. So are you going to be frequently retrieving this object, or are you only going to retrieve this object every once and so often? So you're going to get all these different scenario questions, and it will be asking you to architect the best mechanism for storing your data in S3. And we're going to have lots of practice quiz questions on that as well. So here's a nice little table which basically sums up the different options in our S3 storage classes. We have standard infrequently accessed, and then reduced redundancy storage. And then you can see the durability is the same for standard and standard infrequently accessed, but it drops for reduced redundancy storage. The availability slightly drops for standard infrequently accessed storage, but remains the same for both standard and RRS. And then concurrent facility fault tolerance. So how many facilities can we lose and still have S3 online? Well, for standard, we can lose up to 2. Same with standard infrequently accessed, but with reduced redundancy storage, we can only lose 1 facility. Everything supports SSL. And then your first byte latency, so how quickly can you access your data? Well, it's going to be within milliseconds, and then all our storage classes support lifecycle management policies. Now I'm going to come back to Glacier. Glacier is its own independent service. It integrates very tightly with S3, but it is its own icon, and it has its own landing page in the console. So Glacier is for data archival. It's extremely low cost, and basically it stores data for as little as 1 cent per gig, and is optimized for data that is infrequently accessed, for which retrieval times of 3 to 5 hours are suitable. So if we compared Glacier with standard and standard infrequently accessed, I don't know why RRS is not on here, but it isn't. So we have the same durability, we have a slightly different availability for IA, which we explored in the last couple of slides. The availability SLA, they don't actually give you an SLA for Glacier. And then the most important thing here to remember is that it's going to take you a few hours to do for your first byte latency. And by first byte latency, we simply mean, how long is it going to take you to retrieve that object? Okay, so we now know a hell of a lot about S3 apart from the charges. So what do you charge for on S3? Well, you charge for the following. You charge for the storage, so how much data are you storing on S3? You charge for the number of requests, so this is the number of times or the number of requests that are being made to objects within your S3 buckets. You then have storage management pricing. This is relatively new, but when you store data in S3, you can add a whole bunch of tags to it, and this allows you to control costs, so you can know that this data is associated with human resources, for example, or this data is associated with your developers, and it allows you to track your costs against S3, and so they do charge on a per tag basis. And then we have data transfer pricing, so data coming into S3 is free, but then moving data around within S3, maybe you're doing replication from one region to another, which we'll cover off in a separate lab, but you would be charged for that replication. And then we have transfer acceleration. What is transfer acceleration, I hear you ask, because we haven't actually covered that yet. Well, Amazon S3 transfer acceleration enables fast, easy, and secure transfers of files over long distances between your end users and an S3 bucket. Transfer acceleration takes advantage of Amazon's CloudFront globally distributed edge locations, and the data arrives at an edge location and is then routed to S3 over an optimized network path. So let's see what that actually looks like. So we've got our users, they're all over the world. They might be in South Africa, South America, it might be over in Japan or in New Zealand, but my actual bucket location is inside of London because that's where I configured it when I first set up my bucket. So instead of the users uploading directly to the bucket, what they're actually doing is they're uploading to our edge locations. Our edge locations are much, much closer to the user. And then we have much more superior networking between our edge locations and our AWS region in London. So you can actually accelerate the upload speed of your files. And if you type Amazon S3 transfer acceleration into Google, you'll be able to find this tool, and it actually shows you how much faster it is when you turn transfer acceleration on. So if I go to places that are further away from me, places like Tokyo, for example, or Sydney or Singapore, I can see that it's going to be 37% faster if I have transfer acceleration turned on. Okay, so congratulations, we're coming towards the end of this lecture. You've learnt an awful lot. What are my exam tips for S3? Well, remember that S3 is object-based. You can't install operating systems or databases on it. The performance would just be absolutely terrible. You only want to install files, things like Word files or videos or pictures, etc. Files can be anywhere from 0 bytes up to 5 terabytes in size. There's unlimited storage, and files are stored in buckets. Buckets is just a fancy name for a folder, and the S3 has a universal namespace, so that means that the bucket names must be unique globally. And in the next lab, we'll show you how to create a bucket, and we'll try and take test bucket, for example. So in terms of what the actual link looks like to your S3 buckets, it always looks like this. So it's S3 and then hyphen the region and then .amazonaws.com and then / the bucket name. Do definitely remember that format going into the exam. Remember the consistency models. You have read after write consistency for puts of new objects. So when you create an object in S3, you are able to read it immediately, but you only have eventual consistencies for overwrite puts and deletes. So if you update an object or if you delete an object from S3, it might not show up as deleted, or the update might not show up immediately. It takes some time for this replication to happen. So then we have different storage classes within S3. We've got the normal S3, which is durable, it's immediately available, and it's good for frequently accessed storage. S3 IA, infrequently accessed, is durable, it's immediately available, but it's good for infrequently accessed data. We then have reduced redundancy storage, so this is used for data that is easily reproducible, such as thumbnails, for example. And then we have Glacian. This is for archival data, which you are able to wait between 3 to 5 hours before accessing. You should remember the core fundamentals of what actually makes up an S3 object. So you always have the key. This is the name. Remember, names are lexicographical, so they're stored in alphabetical order across the S3 facilities. You then have the value, which is the data itself. You then have the version of the object. So which version is it? We're going to have a lab on versioning coming up. We then have metadata. Metadata is just data about data. And we then have the sub-resources that exist underneath this object, and that will be the access control list, so who can actually access this data, and then we have support for the BitTorrent protocol. So some further tips, and I keep saying this over and over again, but it's object-based storage only. It's only for your files. Do not install an operating system on it. Do not install databases on it. You can use block-based storage for that, and we'll cover that in the EC2 section of the course. When you successfully upload an object to S3, it will always generate a HTTP 200 status code saying it's been successfully uploaded. My final tip before you sit the exam is make sure you read the S3 FAQ before doing the exam. S3 is one of the fundamental services within AWS, and it's going to come up in your exams a lot. Okay, that's it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture where we start getting our hands dirty and it becomes a lot more fun because we start interacting with S3 in the console.